Hello and welcome to today's video. So in a hover on a calm windless day, helicopter blades produce equal lift at every point in their rotation. It is perfectly balanced around the mast, but the moment that the helicopter begins to move forward, backwards or sideways, that balance is affected by a phenomenon called dissymmetry of lift. To understand why this happens, we have to look at relative wind and the lift that is generated by how fast the air moves across the surface of those blades. Let's look at a typical American-made rotor system spinning counter-clockwise. In a hover, the blade tips are moving at, say, 400 knots all the way around. But now, let's fly forward at a true airspeed of 100 knots. On the right side, the blade is advancing into the wind due to forward movement. You will need to add 400 knots of the rotation to the 100 knots of the forward speed. The total relative wind on the advancing blade is now 500 knots. While on the left side, the blade is retreating. It moves in the same direction as the wind. Here you subtract the forward speed from the rotation minus 100 knots. So you'll have a total relative wind of 300 knots on the left. With lift being proportional to the square of the velocity, that 200 knot difference creates a noticeable imbalance that will affect the performance of the helicopter. The advancing blade wants to soar upwards, while the retreating blade wants to sink. This isn't just a forward flight problem. If you move sideways, dissymmetry of lift follows you. If you move right, your advancing blade is now at the rear. The physics remains the same. The blade moving into the wind will always try to outlift the blade moving away from it. This is what is meant by dissymmetry of lift in helicopters. While in our next video, we will start to talk about compensation for the dissymmetry of lift and gyroscopic precision, which you need to know when talking about lift and where it is acting on the helicopter. Thanks for watching.